get started. Monica, thank you for taking the time to do the mock review with me.
You're very welcome, Miriam.
Today, our topic is design a Yelp. And Yelp is an online rating system for business where user can search and view a business reviews, and they can leave reviews. Now, and the functional requirements are defined here as I just mentioned. User should be able to search businesses by name, location, and category. User should be able to view businesses and their reviews. User should be able to leave reviews on business, and mandatory 1 to 5 star and optional text. Next, I will provide the non-functional requirements. First, the search latency should be less than 500 milliseconds. Anything longer than that, users would feel delays and less motivated to continue to use the application. And we value high availability over an eventual consistency would be fine, which means if just now another user leaves a new review and that changes the overall average rating, and another user is viewing the review, it's fine that this user doesn't see the upcoming review. And then we need to data user support up to 100 million daily users and 10 million businesses. The core entities of this question include users, reviews, and businesses. API routes, which means how does the system, what interface we provide to user. First, when they to be able to view search businesses, user would put a get request businesses / query, and all the query parameter would be optional. User can provide if they are interested in attitude. Category page. We provide paginization because the returned business could be a long list. Partial business. The returned result is matched business based on user's query parameter. So view a business. Get businesses, and this time user would provide a specific business ID. Returns the business and reviews. The last one is leave a review. Post HTTP request, businesses, business ID, and reviews, and return review. And the input would include the mandatory rating 1 to 5 and an optional text review. Optional. User ID. User ID is included in GWT token. That's how the system identify who leaves the review, who is leaving the review. Next, how will user be able to search for business? It starts with the user interact with the client application. I have to refresh the applications. Okay, now. It starts with a user interacts with the client application, and the client application sends the user's request with get certain type of a business. It could be category or with 5 miles near me, latitude, longitude, and or names, etc. And the client application would send the request to API gateway. API gateway, which route the request to the service. In this case, we would call it a business service. Is it too small? And the business service would be responsible for process the query parameter which user put in the request, and then formulate a database query from the business query and return the matched business. The business data would include business ID, name, latitude, longitude, average rating, and etc. Category is important. I would make it double arrow. Okay. This is double arrow 2. Okay. Next question. How will users be able to view a business details and reviews? This is a GET request too, but this time user would send a GET request through interaction with the client application, and the client application would be able to grab the business ID to API gateway, and API gateway routes the requests to business service, and business service fetch the business with matching business ID and return the business data, include name, locations, average rating, categories, and etc. In the same time, it also join the reviews related to join reviews matching the business data. Next question. How will users be able to leave reviews on the businesses? Leaving a review is a post request, which is a write operation. It has different patterns with the view business, because view businesses is a read heavy operation. To allow them independently scale, I would create another service called, let's call it a review service. When the user leave reviews on the client operation, the client operation sends the payload to API gateway, and API gateway grab the user ID in the GWT token and the business ID from the URL, and route the request to review service, and review service write a new row. The review service writes a new row in the review table and return the successfully created review row to the user. Now, how how would you efficiently calculate and update the average rating for businesses to ensure it's readily available in search results and still accurate up to the minute? This is asking read-write synchronization, essentially, to be able to reflect the upcoming reviews. I would choose update the average rating in the time when a new review is added. In this case, it will be synchronously returned to the user who is reading the reviews. To be able to do that, I would add so a problem of doing that is we need to create a new review row whenever a new review is coming, and update the average rating, calculate the average rating in the same time. To do that, we need an atomic transaction to make sure these two transactions happen in the same time. Most databases would be able to provide this atomic transaction feature. I would add I already have that. Okay. A problem for this solution is we use the atomic transaction to control the written and to control the writing and calculating average rating happening at the same time, but still there would be a raise condition when one user is reading the review, but another user, and at the same time, another user is writing the review. And then the user A would read the outdated rating, average rating. To prevent that, I would add a number called written version number. If a user, when it first requests, is saying version number smaller than the expected version number, which means the review is outdated, and the system would return an error. It will ask the user to refresh the data, and then we guarantee the user seeing the updated review. How do you modify your system to ensure that a user can only leave one review per business? One problem if users are able to leave multiple reviews for a business is that they could write multiple negative reviews to harm another business. So we only allow one user writes one review for a given business. The most effective way to do that is to make a composite key for the review table. In that case, the database would ensure that only one user ID and one business ID entries for the review table. In that case, even we have multiple review servers, since they all interact, since all of them interact with the same database, the database would throw an error if they try to write the second review with duplicate composite primary key. How can you improve search to handle complex query more efficiently? Users could use multiple query parameter. They could say, I want an Italian restaurant within 5 miles. In this case, they are querying a category and a location, and like a distance-based location. We need to be able to query, we need to calculate longitude and latitude to calculate the distance. We could use Elasticsearch, which automatically provide full text search for parameters like name, description, category, and such, etc. It also provides geospatial based search, which automatically calculate the latitude and longitude. We should sense, for the user's perspective, distance is the most important and would eliminate the most data. So to calculate efficiently, we should calculate the filter location. We should make the geospatial data first, and then apply other filters such as name, category. Enter the needs, name and category, and use name should be an inverted text, and category just be a text, index. The name would be a reverted index. Oh, I didn't finish. I need to update. This would bring a new problem, which is Elasticsearch wouldn't synchronously reflect all the data, because when a new review comes in, it still writes into the main database. To solve the problem, we can add a CDC, which update the Elasticsearch immediately whenever there's a new update in the main database. Well, there is still a small delay, but it should be fine given the use case. We are done.
Wow, you did a great job. Really tiny mistakes. Very good.